I am now in Sing, and this is my video presentation for AMA1D07. And the topic I would like to talk about is how many different kind of black holes are there. First of all, when we describe black holes, we'll describe it in terms of three parameters. And the first one is the total energy, that is the mass. The second one is the angular momentum, that is how fast is the black hole rotating. And the third one is electric charge of the black hole. And for this topic, when we talk about like how many types of black hole, we're not talking about like the size of the black hole. We are mainly considering on the angular momentum and the electric charge of the black hole. So there will be total of 4 types of black hole. The first one is the black hole without angular momentum and electric charge. The second one is with angular momentum but without electric charge. The third one is without angular momentum but with electric charge. And the fourth one is with angular momentum and electric charge. So the first one is without angular momentum and electric charge. And this type of black hole is called Schwarzschild non-rotating black hole. It's the simplest black hole and the core does not rotate. It has a singularity and event fission. The event fission is located at the Schwarzschild radius far from the singularity, and the area between them are almost empty. So the density of the black hole is low, and the larger the black hole, the lower the density. And the second one is with angular momentum but without electric charge. It is called the Kerr rotating black hole. The black hole recently imaged in AMA1D07 is the Kerr rotating black hole. It also has a singularity, but it's not simply a singularity, but it's ring singularity. You can imagine like it is like a point being pulled into a line and distort in a ring shape. And it has 2 event horizons. The event horizon is the region from which no signal can escape, and the 2 event horizon is the inner horizon and the outer horizon. Also there is a ergosphere. It is an egg-shaped region of distort space around the event horizon, and the region inside which space rotates so fast that it is impossible for a body to hover in such way to appear stationary to a distant observer. And why is called ergosphere? Because ergos is like energy in Greek words, and all the spin energy of a black hole resides outside the horizon, and it can be extracted, like at least in principle. And for a maximally rotating black hole of mass m, the maximum energy that can be extracted is about 0.29 mc². And the last characteristic is the static limit. It is the boundary between the ergosphere and normal space. And the third type is without angular momentum and electric charge. It is called the Rn black hole. It have a singularity and 2 event horizons. One is inner horizon and the second one is outer horizon. And if the electric charge of the Rn black hole keep increasing, 2 horizons will combine into one and form an extremo Rn black hole. And if the electric charge keep increasing, finally the event horizon will disappear, and theoretically a naked singularity will form. But this naked singularity is not being observed and is only in theory. And Roger Penrose in 1973 have announced a cosmic censorship hypothesis and states that there is a rule. It's just like in physics and maths. If a singularity exists or form, it will be hidden behind the horizon. But yet this hypothesis has still not been proved, or is it correct? So this nictus singularity thing is only a theory. And the last type of black hole is the black hole with angular momentum and electric charge. It's called the Kerr-Newman black hole. And this black hole have both the characteristic from Kerr black hole and the RM black hole. It has a ring singularity, and when the angular momentum and electric charge are far larger than the total energy, then theoretically the liquid singularity will form. And this are all the 4 types of black hole I would like to talk about today. Thank you.